Find the volume of the solid created by revolving the curves y equals x cubed, and the line y equals 3/2 as shown to the right. Check, check. Okay. For 0 is less than x less than 1. Okay. So y equals x, which equals x cubed at 1 and 0. And this is probably 3/2. So the idea here is we're going to have a region right here. So we're going to have this region right here. And we're going to revolve it around this horizontal line y equals 3/2. So we'll get something that's kind of like this. Make it like that. Shadow it in. Shade it in. Shadow it in. Okay. And so this is going to be the disk method or the washer method. Or like I like to say, the disk minus disk method. So the formula we're going to use will be pi rb squared minus pi r small squared dx. And I'll write it like this, delta x. So to draw this out, this will be right here. Nope, that's not straight at all. There we go. That's a little bit better. This will be r small, and this right here will be r big, and the delta x's that we're taking will be along this direction right here, delta x. So the idea here is we're going to find each of these, I'll call them washers, but it's really just a disk with a delta x with a small disk cut out from the middle. And this will be, change colors real quick. We got here, this will be R big, here, that'll be R small. And we'll just do the R big minus the R small. So we're making one disk, subtracting out the inner disk, and we're integrating in the x direction. Okay. So enough of a initial setup. So I'll rewrite this as move the pi out here. Nah, I'll leave the pi inside. Pi rb squared minus rs squared. Then I'll leave it as delta x right now. Okay. So now we need to find what r big and r small is. I'll start with r big. So that'll be this distance right here. And this distance is going to be 3/2 minus x cubed. So when x is 0, then it'll be 3/2, which makes sense. It looks like this distance right here would be 3/2. And then when x is 1, it'll be this distance right here, which will be smaller. So that'd be 3/2 minus 1 cubed, which would be 1/2, which seems reasonable. Okay. So now the tricky part comes. We need r big squared, because this is rb squared. So this would be 3/2 minus x cubed squared, which is 9/4 minus, this would be 3/2 times x cubed times 2. The 2's will cancel. And then we'll add to that x to the 6th. Okay? That's our r big squared. Then we have r small, which will be 3/2 minus x. And then r small squared will be 3/2 minus x squared. One of the human performance traps that you might come across here is you would think, oh, x and x cubed, and you'd forget to do this 3/2 here. So what we really do is we need to have a 3/2 minus this value, because the axis of rotation is up here at y equals 3/2, not like the x-axis. So that's a small human performance trap you should watch out for. That's one of the reasons why I look at the endpoints. I'm like, all right, does this make sense at 0? Does this make sense at 1? If it makes sense at those 2 points, then there's a better chance that it makes sense overall. Okay, back to r small. 9/4 minus 3/2 times 2 times x squared plus x squared. Okay, and then we'll cancel the 2's. Okay, Change colors. Green. Now what are we going to do? We're going to plug everything into our equation we had over here. So we're going to bring this down. Pi integral. Feels like there's going to be some overlap here. It's okay. So we have 9/4 minus 3x cubed plus x to the 6th minus quantity. Looks like we're going to do a lot of power rule as well. 9/4 minus 3x squared. 3x. There we go. Plus x squared. And it makes sense that we have a negative. Okay. And then we're going to distribute the negative. And we are left with pi. Let's see, the 9/4 go away. And we're left with x to the 6th minus 3x cubed plus 3. No. I'm going to do it as minus x squared plus 3x. I just like to keep the going from highest to lowest power. Helps keep things straight. Okay. So then from here, this is just straight power rule now. So we did the setup. Everything was logical, made sense, kind of reasoned through it. Then we put in the math, and now all the logic and reasoning basically gone. Now this is just straight mathematical calculations. No thinking. Well, use a little thinking, but don't go overboard. Okay. And this will be from 0 to 1, because we're going along the x-axis from 0 to 1. So we have x to the 7th over 7. That's going to be hard for the common denominator. X to the 4th over 4. Maybe it's 28. X to the 3rd over 3rd. Yeah, it's going to be a big common denominator. Two negatives, yep. Plus 3x squared over 2. Okay? So, what I'm going to start with, there's probably an easy way to do this. I don't know what it is. I'm going to do a common denominator of 12. So this will be minus, this will be times 9x to the 4th minus, times by 4, minus 4. This will be plus over 12. 6 times 3 is 18 plus 18. Okay, so what I did was I converted everything to a 12 common denominator. So this one is multiplied by 3, that one is multiplied by 4, that one is multiplied by 6. And this gives us x to the 7th over 7. And this is 9 plus 4 is 13. 18 minus 13 is 5. 5/12. I'm going to say we're evaluating this from 0 to 1. So, sorry, backtrack slightly. So I'm going to go up here. I'm going to evaluate this from 0 to 1. All the zeros go away. And all the ones go to just 1. So we have 1/7 minus 3/4 minus 1/3 plus 3/2. So that's the calculus portion here. So what I did here, you evaluated from 0 to 1. And then there's a pi. Whoop, don't forget the pi. What I did was I just really quickly evaluated from 0 to 1. X to the when x is 0, it doesn't matter what power it goes to, it's always going to be 0. And from 1, it doesn't matter what power 1 goes to, it's just going to be 1. So it's quick for me to do that. And I kind of jumped ahead here trying to do the common denominator. Now I'm going to try and do the common denominator. But all these x's then go away. So we're now left with, I'm going to cross this x out and write it 1. We have 1/7 minus 5/12. And 7 times 12 is, no, 7 is prime, so there's no greatest common denominator. Well, I guess it's 7, or 1. 14, 7 times 1 is 7, 84, okay? So we have 84, and then we're going to have 12 minus 5 times 7 minus 35, which is a lot, which doesn't, makes me suspicious here. Plus. plus. Okay. We shouldn't have a negative volume. And then there's still the pi involved, which I've been neglecting. You should never neglect the pi. This will be 47 over 84 pi. There we go. Common denominator solved. Let's see what we got here. Even looks like maybe possibility. Look at this journey. Such a journey. Did not mean the journey to be that long. Okay. Erase this 3 that's crossed out. You're ruining my gig here, 3. Okay. 47 over 84 pi. Yep. So this will be the answer. So, backtrack. I know, real confusing with all the algebra. My boardmanship when it comes to algebra, it's kind of flaky at best. And it's so boring that I try and go through it quickly because if I'm bored, you're bored, everyone is bored. No sense in being bored. Okay, focus. Find the volume. So we have these two curves, y equals x cubed. We're supposed to find the volume created. We revolve this about a line that's not the axis. Specifically, this line is y equals 3/2. So we write up our equation of the washer method or the disk minus disk method. And this is pi r big squared minus pi r small squared. And that's just two disks, one disk subtracted from the other. And then we draw up where our radii are r big and r small. And this one's going to be 3/2 minus x cubed. This one's going to be 3/2 minus x. And then we test the endpoints, kind of make sure that, yeah, these are possible, these look reasonable. Then we plug it into our equation. Don't forget to FOIL. Massive amount of algebra, more algebra. Substituting ones and zeros in, which is nice that we had ones and zeros and not something else that was difficult to take to a power. So we take that, find a common denominator, go crazy with the math, and then eventually we get 47 pi over 84. So the hard part here, and specifically the calculus part, is only like the first couple steps here. Everything else, mostly algebra. And that's where a lot of you're going to be error prone is with the algebra. On the AP exam, you have more focus on calculus and less focus on the algebra part. So the part to really understand here is just really the first couple steps. So that's how we approach this problem. Hope it helps you. I thought it was fun and interesting. I will see you guys on the next one. Thank you much.